Hello, class. This is the recorded lecture for section 2.2 in the trigonometry book. And this is again talking about trig functions on the definition using the unit circle. And so what we're first going to do, and some of this I've alluded to already in the last lecture, is that we're going to define the trig functions using the unit circle. And basically the trig function is the y value is the sine and the x value is the cosine. And we've talked about that. Then we're going to show you again how to make some calculations using our table. And then talk about some identities again that we've alluded to in chapter 3 when we talked about it as well. And so the idea of moving clockwise and counterclockwise, which again, clockwise is negative, counterclockwise is positive. And by our definition, we are defining that the amount that you move on the unit circle, which is the angle, right? And they use that terminal point T, where the y value is sine, and the x value is cosine. And tangent is y over x. And the cosecant, secant, and cotangent are just the opposites. And so when you take a look at those definitions, they were the same ones that we alluded to in our sheet that we have here. And I think the best thing now is to walk through an example or two to illustrate these equations here. So let's take a look at a couple of examples. So let's take a look at, for example, if the angle or you travel around the unit circle pi over 3, which would be 60 degrees, right? And so if you take a look at our table, pi over 3 is 60 degrees. And so what are the values? So let me pull up the whiteboard here. And so if the angle is pi over 3, that's 60 degrees. Look at our table. And so what would be sine of pi over 3? If you look at our table, that would be square root of 3 over 2. And what would be cosine of pi over 3? That should be 1/2. And then tangent, pi over 3, would be square root of 3. And remember, tangent is, remember sine is the y value and the x value. So if you plotted that point, 1/2 square root of 3 over 2 would be right on the unit circle. And what's interesting here is remember that sine is y over x. And so let's plug these in. If you get square root of 3 divided by 2 divided by 1/2, you see these halves cancel, and that's where our square root of 3 comes in as well. So literally, once you know sine and cosine, you know everything else. And I won't go through the other ones, but say cosecant pi over 3. Instead of that being the inverse of sine, so that would be 1 over y. And so this would be 1 over square root of 3 over 2. And so when you flip that, it's going to be 2 over square root of 3. And as you know, and I don't agree with this, but the math, the math gods don't like to have a square root in the denominator. And so when you do that calculation, you multiply the top and the bottom by square root of 3, and you see that you get 2 square root of 3 divided by 3. And so if we go back to the PowerPoint, you can see that here we have all the values calculated for you. And just like we did in chapter 3, we introduce our fancy chart here where sine, cosine, and tangent are defined, and they even put in cosecant, secant, and cotangent. I usually just derive them once I get sine, cosine, and tangent. Again, in my life, I only use sine, cosine, and tangent. The other three I never used. But once you know the three main ones, you just inverse for the other three. So one thing that we have to keep in mind is that when you look at these equations, there are, except for cosine and sine, all the other ones have a possibility of being undefined. And again, we did talk about this in chapter 4 or chapter 3, but just to refresh your memory here a little bit. So if we look at sine of 0 degrees. Well, what sine is 0 degrees? Well, sine of 0 degrees is 0 when you look at that. And so if you think about it, what is cosecant of 0 degrees? Well, remember, this is the y value, right? And this is 1 over y. And so what happens? Can't divide by 0. So this is what we call undefined. And so cosecant is undefined when sine equals 0. Secant is undefined. Right? Remember, that's 1 over x when cosine is 0. And tangent is also undefined because tangent, remember, is y over x. And you can't divide by 0, so it's also not defined when cosine equals 0. And so you just have to kind of look at that part of it. And, you know, when you walk through these calculations, hopefully it becomes more obvious as you do more of these. But, you know, just be aware, just like we were in algebra, that you can't divide by 0. So what we're going to do here now is, using the unit circle approach, find the values of these trigonometric functions. And we've been doing this already. And so very similar strategies. What's the strategies? Well, you go around the unit circle, the amount of angle, figure out what quadrant you're in, and then find the, I call it the reference angle. I like to use the one in chapter 3, and figure out the, using the table, calculate what that value would be. And so let's not do the first one. Let's do the bottom two. So and I'll just do this on the whiteboard. So let's do tan of minus pi over 3. So again, when we travel minus pi over 3, I like to think about it in degrees. So that would be 60 degrees. So we travel 60 degrees this way. So that's minus 60 degrees, right? So you generate, and now this is our, they called it reference number. And so this angle here, theta, is 60 degrees. And so when you do the calculation for tan, we're in the quadrant 4, right? So x is positive and y is negative. And so tangent should be negative. So you go to your sheet, and tan of 60 degrees is square root of 3. but we know it's going to be negative, so it'd be minus square root of 3. Okay, well, let's do one more. And this last one is kind of a ridiculously mathy problem, but it kind of gets to the point. So here's what I like to do. So this is 19 pi over 4, which is a crazy number, right? Crazy angle. So it's way bigger than 2 pi. And so you're going to be going around this circle many, many, many times. And the question is, how many times you go around and then where do you stop? And so you think about it, every time you go around 2 pi, you end up back in the same spot, right? And again, remember, you go around, and that would be 2 pi. So if you think about it, and because 19 is such a big number, maybe we could just do this in radians, just for those of you that like to think of radians. Well, if we're looking for a common denominator, it would be 4, right? So 2 pi is the same as 8 pi divided by 4. So if you think about it, you have 19 pi over 4, right? And you go around once, which is 8 pi over 4. What's left? Well, looks like 11 pi over 4, right? And so looks like we can go around one more time, right? So you go around again. So another 2 pi. So let's subtract another 2 pi. And now we're left with 8 and 11 should be 3 pi over 4. And so we're going to travel another 3 pi over 4. And so that would be 3 over 4 times 180. And so that would be 45, right? So that would be 135 degrees. So let me just pick a different color here so you can see. So now we're going around 135 degrees. And so when you go around 135 degrees, you're going to find that angle right there. I call it theta. And so theta is going to be 180 minus 135. And that would be 45 degrees. And so we're looking for sine of 45 degrees. We get out our table and we get square root of 2 over 2. And we're in quadrant 2 now, right? So this is quadrant 2. And you can see the y value is positive. So you get positive square root of 2 over 2. So that's the first part of the recorded lecture for section 2.2. I will finish it in the next lecture.